Nuclear changes in radioactive decay. Spontaneous radioactive decay was discovered by Henri Becquerel in 1896, but it was not understood until the model of the nucleus had been developed. That came along in 1932. At this stage, scientists knew that in radioactive decay, charge is conserved and nucleon number is conserved, that is, number of protons and neutrons. First, to look at alpha decay. An alpha particle consists of 2 protons and 2 neutrons. It's a helium nucleus. This is ejected from the nucleus, as shown below. We can represent this for an unknown element x with the symbols shown here. The unknown element x has proton number Z and nucleon number, i.e. protons and neutrons, A. The alpha consists of 2 protons, and so Z is going to reduce by 2 in the daughter nucleus Y. The alpha has 1, 2, 3, 4 nucleons, so the nucleon number will reduce by 4 in the daughter nucleus. And there is the alpha particle with proton number 2 and nucleon number 4. We can represent this with a real element that undergoes alpha decay. Here we have 238 uranium. It will lose 2 of its 92 protons to become thorium with proton number 90. It will lose 4 of its nucleons to have a nucleon number of 234. And here is the alpha particle with nucleon number 4, proton number 2. You'll notice that 90 plus 2 equals 92, so the proton number has been conserved. 234 plus 4 equals 238, so the nucleon number has been conserved. Now to look at beta minus decay. A beta minus particle is simply an electron, and it comes about when a neutron turns into a proton, ejecting the beta minus. An electron antineutrino is also ejected, and you'll find out more about this later in the course. I've highlighted this neutron, which is the one which will spontaneously turn into a proton and eject the beta minus particle or electron. In symbols for a general element X with proton number Z and nucleon number A, one of the neutrons has turned into a proton, so the proton number will increase by 1. However, a neutron was included in the nucleon number. This proton is now included in the nucleon number, so the nucleon number A does not change in going from parent to daughter. The beta minus particle we can represent with the Greek letter beta, or it's sometimes just represented with a lowercase e for electron. To make the numbers either side balance, here we have Z is equal to Z plus 1 minus 1. So the beta minus has to have a proton number of minus 1. A is equal to A plus 0. Therefore it has a nucleon number of 0. This symbol here represents a neutrino. The subscript lowercase e tells us it's an electron neutrino. There are other types of neutrino. And the bar across the top tells us it's an anti-neutrino. It's antimatter. For a real element that undergoes beta minus decay, I've taken carbon 14 with a proton number of 6 and nucleon number of 14. It has 8 neutrons, 14 minus 6. If one of the neutrons turns into a proton, we will go to 7 protons, making it now nitrogen. The nucleon number stays the same. We again have the beta minus particle and the electron anti-neutrino. Beta plus decay. In this case, a beta plus particle, which is an anti-electron, antimatter, often called a positron, is emitted. In this case, a proton turns into a neutron, ejecting the beta plus. An electron neutrino is also ejected. This is the proton which is going to spontaneously change into a neutron, ejecting an electron neutrino is also ejected. So this is the proton which will turn into a neutron, ejecting the beta plus particle. This has the same mass as an electron, but the opposite charge, a charge of plus 1.6 times 10 to the minus 19 coulombs. In symbols for the unknown element X, it has proton number Z, and as one of the protons has now become a neutron, the proton number drops by 1 in the daughter Y. Proton or neutron, it's still a nucleon, so the nucleon number remains the same. This is the symbol for the beta plus particle. Sometimes, instead of the Greek letter beta, a lowercase p is used for positron. And this is the electron neutrino. Looking at the specific case of sodium 22, which has 11 protons. As one of the protons has become a neutron, this reduces to 10 in the daughter, which is now neon. The nucleon number remains the same. This is the beta plus particle and the electron neutrino. You notice that 11 is equal to 10 plus 1, 22 is equal to 22 plus 0. Finally, to look at gamma radiation, this is simply high-energy electromagnetic radiation emitted from the nucleus. It has no charge, no mass, no nucleon number, and so does not alter the makeup of the nucleus it leaves.